getting started on the next batch of 10 amino acids. Next up is lysine. Lysine is positively charged, so it's a cation, same as arginine. So here you can see lysine, and we talked about it briefly when we were covering arginine. You have somewhat of a hydrophobic side chain ending in a positive charge. So I'll draw it here, alpha carbon, carboxylic acid side chain, carboxylic acid group on the right here. And lysine is going to have 4 carbons in the side chain ending in a nitrogen. And the nitrogen at cellular pH will be positively charged. I'll just, I didn't show the hydrogens on all these, and then I'll just search for it to show what they draw it as. So here's the alpha carbon and the side chain coming down here. And you can see it on the side here. Fairly long hydrocarbon side chain ending in a nitrogen group. And I think the end of the side chain should be similar to ammonium. It should be a positive charge, even though there's resonance and there's no single hydrogen that's carrying the positive charge. It's kind of, as far as I know, distributed kind of equally in the space. So lysine, the symbol LYS for the 3-letter symbol, and K for the single letter symbol. And K is used because it's 1 letter away from L, and the letter M was already used for methionine. It is essential. It cannot be produced by the human body. It was discovered looking at protein from casein in milk, the protein casein. It was named lys because of something related to that discovery, or at least named by the discoverer. And according to Wiktionary, it's in reference to its tendency to participate in catalysis, where lys is indicating that it's cutting. That's well, at least with the breakdown of molecules, I'm assuming it's the same kind of similar to the word lys as used in the context of cutting or breaking bonds. So alpha lysine is relatively favorable in alpha helix. It's right here, 0.26 on the helical penalty. Relatively close to alanine, which is the most favorable. And we saw this with arginine. Lysine shows up a reasonable amount in the homeodomain protein fold. So this is a protein fold that binds to DNA, so it has an excess of positively charged amino acids. So you can see the lysine highlighted, and now you can see the arginine highlighted. And lysine also provides positive charge on histone proteins, that help organize DNA in chromosomes. Again, arginine is also found alongside lysine in these histone proteins. So lysine is also involved in, it's methylated as a signal. A methyl group is added to the lysine side chain in order to signal other molecules during gene regulation as part of epigenetics. And lysine, being positively charged, is going to be hydrophilic, and so it'll be found on the outside of proteins that are exposed to cytoplasm or inside in the interior of proteins, as long as there's a kind of a negative charge from aspartic acid or glutamic acid that's able to cancel out the positive charge. So it'll be like a pocket of neutral charge with equal numbers of positively charged side chains and negatively charged side chains in the interior of a protein.